Hello everyone. So today we are going over 9.2 day 1 notes. The learning objective is I can convert between exponential form and logarithmic form. First, let's start with a warm-up. We need to find the value of x. So if we're looking at problem A, we have 2 to the x power is equal to 4. We need to try to figure out what x is. So we know that 2 squared is equal to 4, so x must equal 2. And if we double check that, 2 squared is equal to 4, and since 4 is equal to 4, this is a true statement, so x must be 2. For letter B, we have 2 to the x power is equal to 5. Now we know that 2 squared is equal to 4, so let's try if we do 2 to the third power, we're going to get 8. So that's too big. So we know it needs to be somewhere in between 2 and 3. So let's do 2 to the, let's try 2.5. Still too big, so let's go a little smaller. 2 to the, let's try 2.3. Okay, we're getting closer. Let's try to add in another decimal. So we have 2 to the 2.32. Okay, we're at 4.99. Now we could keep going on, but for right now, let's just say x is around 2.32. Okay, so how did you figure out how to solve part B? What we just did was a guess and check. Luckily, there's a function in mathematics that helps us solve for an exponent. It's called a logarithm. We write this as log of x. This is the opposite or inverse of exponentials. The following equation conversions are a useful tool for solving exponential or logarithmic equations. So we have b of x is equal to a. This is exponential form. Over here we have log base b of a is equal to x. This is logarithmic form. Exponential form has an exponent. Logarithmic form will have log in it. So today we're going to be converting between exponential form to logarithmic form or logarithmic form to exponential form. B is the base in both types of equations. The base of an exponential is the base of its logarithm. Remember that the base stays in the same place while the x and a, sorry, that's a typo on my end, switch sides when changing between the two forms. So let's try an example down here. So in exponential form, we have 6 to the third power is equal to 216. We want to try to make it into logarithmic form. And a trick to help you guys is to follow your heart. Log base 6 of 216 is equal to 3. Let's try that one more time. Log base 6 of 216 is equal to 3. This also works if we want to go from logarithmic form to exponential form. Your words just changed just a little bit. So I'm going to do, you always start at your base. 6 raised to the power of 3 is equal to 216. 6 raised to the power of 3 is equal to 216. Let's try some practice problems. So again, we want to go between exponential and logarithmic form. We want to fill out the blanks. So we have 2 to the third power is equal to 8. So log base 2 of 8 is equal to 3. For the next problem, we have a logarithm. We want to change it to an exponential form. So 3 raised to the power of 4 is equal to 81. In the next problem, we see that the exponent is a fraction, but don't let that trip you up. We treat it the same. Log base 4 of 2 is equal to 1/2. And for the last problem, we have 3 raised to the power of -2 is equal to 1/9. To try some on your own, this would be a good spot to pause the video, try these, and then unpause and we'll go through them together. Okay, let's go through them. So again, these are in exponential form. These are logarithmic form. So we want to try to convert and fill in the missing blanks. So here we have log base 2 of 32 is equal to 5. Log base 2 of 32 is equal to 5. Log base 8 of 512 is equal to 3. Log base 4 of 1/16 is equal to -2. Now we want to make them into exponential form. So 3 raised to the power of 2 is equal to 9. 8 raised to the power of 0 is equal to 1. For this last problem, we have log of 100 is equal to 2. The common log with no base will always have a base of 10. So this can also be written as log base 10 of 100 is equal to 2. You can also add in that little 10 right there so you don't miss it. So now 10 raised to the power of 2 is equal to 100. Last part of the notes. The other important log is called the natural log. We write this as ln of x. It is a log with base of e. E to the first power is just a number. It's as if we were giving you pi. We all know that pi is a number. So e is also just a number. We can convert it the same exact way, except when we're converting and we have an e as our base, we always use ln. So ln base e of 2.7182818 is equal to 1. So again, this little base would be an e. Let's go through 3 more problems. So we have ln 12 is equal to 2.4849. Since it's ln, the base is an e. So e raised to the power of 2.4849 is equal to 12. Again, since our base is e, we're going to actually change it to a natural log. So ln base e of 0.04979 is equal to a -3. And then for the last one, we know our base is an e. So e raised to the power of -2 is equal to 0.13534. Thank you all for following along with the notes. There's extra practice problems posted on the Haiku page. If you have any questions, make sure to reach out to me. Thank you.